I designed these spool cars so my students would have something to work on in the classroom that they could engineer and put a little bit of themselves into. I didn't want to give them something to just make and operate. And as I've refined the idea, I've been trying to come up with ways that they could easily iterate. They could easily switch out the wheels, they could switch out the bands, and I think this version allows that. You can see right here I'm doing a 50-second pit stop where I take the wheels off, put the wheels back on, and they're ready to go again. The main variables I wanted students to be able to manipulate were the wheel design and the number of bands. But in addition to that, this spool car offers a quick release. You can see this little black gadget right in the center of the bands. That allows the bands to release from the spool so that the car can keep rolling. The original version of the spool tractor or the spool car would roll until the bands untwisted, but at the moment that they untwisted, they'd start twisting again, and the car would slow down and stop and maybe even roll backward. This one can keep going. The assembly's going here at 3 times normal speed. I think you can see everything you need to see. So those are the machine screws. They're pretty tight. They need to be tight so they don't slip out. Now I'm hot gluing in the 1/4-inch poplar dowels. I couldn't decide whether to put the hot glue in the holes or whether to put it on the dowels, but it seemed like it worked well on both sides. Next step is to drill some little holes right in the center of these. They're about 6 inches long, the dowels are. And I can't remember exactly how big these holes are, but they're just a little bit bigger than the nails I had. And the nails, I believe, are 4D nails, so that's probably a little bit smaller than 1/8 of an inch. Now I'm bending the wire. If you've seen the other spool car videos, this works the same way. I just have to be careful to do all this in the right order. So those projections that stick out of the hubs, need to thread those onto the wire first, then bend the hooks, then measure about 2 inches from the end because these projections are a little thicker than the wheels and nuts in the version 2.0. So you can see I did that right angle bend after sliding the hubs up next to the hooks. Now I'm assembling, putting some wheels on. These are wheels that I laser cut. They just have holes that line up with holes in the hubs and that line up with the screws. Right here I'm just putting a nut on one of the screws on each side. You don't actually have to have a nut on any of the screws, but you could do it on all of them if you want it to be a little firmer. So here I'm going to put just a pin that I've made out of some of the wire. It's going through the holes that I drilled earlier. I wound it up. Here it goes. That's normal speed right there. Now this is what I call the rubber band keeper. It has a hole in the middle, and the hole receives a pin, and the pin is a release mechanism. It's like it throws out. So as the wheels start to spin around, the momentum, people call it centrifugal force, but it's the momentum of this pin, or the inertia, is going to throw it outward. And that other black piece right there, I call that the pin keeper. That's going to keep it from flying out in the room. So if you heard a snap there, that was the pin flying out and hitting the keeper. So this is a skateboard bearing version, which will go for a lot longer. If you're looking for something to go a greater distance, this one just keeps on going. And in the next steps here, I'll show you how this is assembled. There's a press fit. You press these skateboard bearings into these hubs, press some bushings into the bearings, and then they just fit on a wire just like the other hubs fit on a wire. If you don't have laser cut wheels, or if you have, in this case, some old laser cut wheels that were made for an earlier model, you'll need to poke a couple of holes so that the screws will line up, the screws on the hub. And I've made this little jig. It's one of the 3D printed parts that I've included in the Instructable that I made for marking the holes. But you could just take the hub, put the screws on here, and use the screws to mark. Also, the hooks are not going to fit through those holes right there. So in just a second, you're going to see me taking my utility knife and cutting them out. I'm also reaming out these locations so the screws can fit through. I think that's a 16D nail. So here goes the utility knife. This is how I cut the centers out when there's no opening there to work with. You can see I'm not worried about it looking perfect. I just make what looks like a little tic-tac-toe board in the center. These are all the parts that I've included in the Instructable in the form of STL files. This would represent a full set of what you might need to do everything you can do with Spool Card 3.0. These two that I'm highlighting right now, moving around a little bit, those are the inside. This is the inside hub and this is the outside hub. And you would need two inside hubs to connect with dowels, and then these two outside hubs have the wires going through them. These are alternative outside hubs that you can push a skateboard bearing into, and these are bushings that go inside the 5/16 inch opening of the skateboard bearing, and then the wire goes through that smaller hole. So that would be substituting for these. These are higher friction. Sometimes I kind of like the higher friction for doing some physics stuff, and it's simpler if you don't have skateboard bearings. This is the pin keeper. This snaps onto one of the square dowels and catches the release pin, and the release pin goes into this. This I'm calling the band keeper. So the bands go through these little rectangular cross-section areas right here, and the release pin goes in that hole where my I have some other spool car videos. I'm going to be adding the links in the space below. I think I showed you how that worked. It might have been kind of fast. And then finally this is just a jig for marking hole positions, so that if you make a cardboard wheel by hand or without using a laser cutter, you can put this center hole over the center of the wheel, and these are the positions that you need to poke holes, where you need to poke holes, so that the screws from the hubs will fit into the wheels right.